Welcome. It's good to see that so many people are staying till this last session. It's great. First of all, to keep you awake, I did a hidden request for change within my presentation. So anyone who notices it, just jump up and can get a stroopwafels from the Netherlands. And actually, I have a second one of stroopwafels, and actually that's for a safe employee that jumps up and says, well, I'm going to make sure that RFC is going to be in FME, next FME version. So I hope I will get rid of both of them. All right. I'm Michiel Schram from the Netherlands, from Sweco. Just a short talk, 15 minutes, so I'm not going to introduce the company. I'm going to right to the point, geometrical tolerance, and what's it about. Actually, it's about slivers, gaps, and holes. Slivers are just the little ones you actually do not see, the long ones. The gaps are in between polygons, and the holes are things within polygons. And they're always an annoyance to data experts, and actually everybody wants clean data. And yes, FME can help you out. I'm using it every day, and well, I can get clean data with FME. I'm going to give you a real-life example of the mapping of habitat types in the Netherlands. I was responsible for the harmonization of all habitat types in the Netherlands. It's a data set of 160 different areas over several millions of polygons and from different provinces, and I put it all together and made one clean set out of it. Let's zoom into the Naardermeer. It's an area near Amsterdam. It's the oldest nature reserve in the Netherlands. And actually, we zoom into a little spot which is mapped. So a lot of polygons were made with certain habitat types, mapped habitat types. Actually, at this moment, you do not see any errors. But there are. There are slivers. There are gaps. And of course, there are some holes. So geometrical issues you really want to get rid of. A lot of people say, well, why? Why? Why do you want to get rid of it? Because actually you do not see them, so why get rid of them? And actually, why is the problem? First of all, to avoid juridical, and second, technical issues. Because this data is used for legislation. This data, permits are given on this data. So actually, you don't want to revoke a permit because of some sliver. That's not something you want. And technical issues, this data is transformed into a post-GIS database, and all processes are run over it, and when there's lots of junk within the data sets, then errors can happen. So that's not something you want. Transformers that can help you out within FME. It's the sliver remover, it's the snapper, it's the donut hole extractor, and it's the area-on-area overlayer. These are things you can use. Actually, in 2017, and the next version, they really made great improvements on it. But me, myself, I'm very fond of my old Python script that was created about 10 years ago and does the job for me. So you can use this. It's possible to use this, but I was so glad the feature reader and feature writer were introduced, so I was able to use my old algorithm, which I'm used to using. So I'm using the feature writer, the system caller, and the feature reader again. Let's see what it looks like. Well, I have a data set, and I have a custom transformer, the clean polygon, and it ends up in a clean data set, the overlapping features and eliminated features. And I've just a parameter of a tolerance. In this case, I'm using a tolerance of 1 meter because it's pretty rough data and doesn't matter that that's a meter apart. And actually, the custom transformer looks like this. And I'm going to explain it to you. First, the input, it's filtered. Well, only polygons are getting through. I'm doing nothing with the attributes. I'm only altering the geometry. So I'm putting a unique ID to it. And after that, I'm going to write it to a shape, the good old shape. After it's written, and I can write it to one shape, but also can write it to several shapes because of performance issues, then I can, the summary is outputted and I explode it so I can make variables out of it. And then the magic happens. The Python script is called. Actually, at this point, I can use the Python caller, but I decided to use this approach because the script is within a subversion, so I just want to call the script and not get it into my workspace. And after that, when it's the magic is done, I can read a table, and I can read the clean geometry, and I can merge it again to my end result. So this is what the Python script looks like. It's an old one from the US. It's a super region poly. You can find it still. You can still find it on the internet. It's a great one, and it really does the job. We're merging it, and I'm using my new feature merger. And actually, it has an auto join in it, so I do not have to put in several parameters. I just can hook up and then get going again. Nobody wants strobe waffles. No. Is this within FME, this function of an auto join? So when two data sets come in, with both have an ID, then it automatically joins because of they both have it within FME. I think it would be great because it saves me lots of time working with PostGIS. I see somebody from SAFE jumping up and getting the strobe waffles.
Before I take the strobe waffles, you mean that what you're really saying is that if you're using a feature merger and you're connecting two things in, if it has the same field on
Yep.
auto-populate it.
Yeah.
Is Harvinder here? I think you should give him the strobe waffles.
Harvinder says that Dale's going to do it.
Okay, let's keep going. Another feature merger, this time the normal one. And after that, a test filter to see if there's overlap or not. And this way we can get the clean, the overlap, and the eliminated features. Well, this was the geometry before cleaning. We're zooming more in with the geometrical issues, with the slivers, with the gaps. There are no holes at this point. And this is the situation after cleaning. So you see, not much has been done on the polygons, but the slivers are gone and the geometry is much better. Actually, for this particular case, the question came in the end. For this particular case, for the whole of the Netherlands, it was 2.5 gigs without cleaning, and it reduced it to about 500 MB after cleaning. It was really a big thing. And all the ecologists didn't see it at all. They were not aware that their data got cleaned, and so it was a great job. Okay, let's get back to the strobe waffles. I still have some more left. I think strobe waffles are two cookies that are glued together with strobe, with syrup. I think that FME is pretty good at gluing things together, and I really like that approach. I really like that you can get whatever out there and glue it together with FME and make it work and make the process going. So I think we should make Canadian strobe waffles out of it. So thank you for listening. If you have any questions, you can ask, or afterwards you can come to me. I'm all week there. So thank you for your attention.
How do you know which of the parallel lines is the right one? If you have a slider. You have polygons that do not touch each other. There's a gap. So which one you pick?
This particular.
Because if they are even a meter away, there's a meter of land for someone.
Yep.
How do you pick the right
This particular algorithm takes the middle. So when there are two, it takes the middle of it. So, and there are lots of different algorithms out there. There's lots of juicy stuff out there that you can use. And
So are you saying that this cannot be done in FME tools, with FME transform?
it can be done, and it will improve even more in the past coming years. So, and FME is really looking for user input to improve the tolerance thing. But it also can be done with other scripts and things, and that's great about FME. Yes?
What functions in the Python script can you not do at all in FME? Like, are there certain ones that you wouldn't be able to pull across and do within FME?
This script, well, I had to use it because in 2016 the snapper, the segment snapper wasn't done yet. So I had really had problems getting it through FME. They say it's now over, so I can do it with FME now. But that was a thing I wasn't able to do with FME. So the segment snapping.
I might actually put the geometry team on the spot right here. We have Kevin and Olivia here. It is absolutely true that FME has been intolerant for most of its life. It hasn't understood tolerance at all. But we've been doing work for several years now, the two of these particular, Olivia especially, and Kevin or Olivia, you want to talk about where we're going with this? We know we still have a journey ahead, but
Yeah, I mean, I think there are many, many different pockets of problems that people have with tolerance in their data, slivers, gaps, overlaps. So I think, you guys all have your own areas where this causes problems, and it might not be as the same kind of specific thing as the person beside you, but overall, we kind of share the same pain. And older FMEs were very accurate, but ended up with lots of little bits of line or polygon all over the place. And as we all know, people, while they may say they appreciate accuracy and precision, it's not usually helpful to have something the size of an atom or a little tiny hole in a donut that's a sliver. So we have been adding gradually more and more processing to help clean data. Geometry validator, we have spike remover, the sliver remover, also specifically was for this kind of coverage problem, as well as in snapping. There's a new mode in the snapper that's a segment snapper that should be able to, with the right tolerance, I think, with the data that we had there, would kind of clean that up.
Yeah.
As well as the generalizer can reduce unnecessary nodes where you don't need that accuracy, which is also part of your Python script. So that Python script that he used kind of bundled together a bit of generalizer as well as, say, segment snapping. But right now in FME today, I guess it's kind of traditional FME thing where you have several steps that you do. Do you want to, say, snap up polygons together, get rid of gaps and overlaps, then do some generalization, then, do some geometry validation, get rid of polygons that have snapped down to nothing, dimensional collapse. And in the future, where we're going is we want to be able to have some of these options like tolerance on the transformers themselves, like the overlayer, the dissolver, the clipper, the intersector. In our office already, we have versions that have them on that we're testing. And that would, at that one, transformer, allow you to get rid of some of these problems by using a tolerance factor directly in one step. And it's not the same thing as a transformer hiding two separate steps right at the base core level. As we're doing the processing, we're taking tolerance into account during the one step of processing. And so it's a big fundamental change in how we do processing in the core, and expect to see more of that. And like you had said, we really greatly appreciate feedback on what kinds of settings you want,
No, no, no. It was some kind of cooperation, of course.
Yeah, fantastic topic. Thank you very
Okay.
much. And
Yep.
give you a round of applause one more
Thank
time.
you.